Okay, let's talk about a superpower you probably already have and might not even know it: biology. Seriously. I'm not just talking about that class you had to take in high school. I mean, biology as a way to understand, well, pretty much everything. Because some of the biggest, toughest questions we're all grappling with right now, they're actually biology questions, and how you answer them really matters. For instance, should we be using brain scans for lie detection? I mean, it sounds like something straight out of a sci fi movie, right? But it's becoming a real possibility. We're talking about taking all those incredibly complex biological signals firing off in our brains and trying to boil them down to a simple true or false. Whether we should do that, well, that's a massive ethical minefield, and its roots are planted firmly in biology. Or what about this one? Is an endangered moth's habitat more important than building a new highway? This is that classic tug of war, isn't it? Progress versus preservation. And look, to have any kind of real conversation about it, you've got to understand the biology. Things like ecosystems, biodiversity, and just how critical one tiny little species can be to the whole shebang. And then you've got the questions that hit really close to home. Stem cell research. Would you vote for it or against it? This stuff isn't just abstract science in a lab. It's about our health, our ethics, the future of medicine for our families, and your opinion, your vote. That actually helps shape what's possible. So you see the pattern here, right? Whether it's cutting edge tech, the environment, or our own bodies, the bottom line is this: an informed answer to any of these questions really requires a solid understanding of biology. It's the tool that lets you cut through all the noise and get to what's really going on. Okay, so we've talked about these big society level questions. But this stuff isn't just out there. It gets personal. It all starts with you, your health, your biology. Think about it. Every single day, you make dozens of choices that are, at their core, biological decisions. What you eat for lunch, whether you hit the gym or the couch, even what time you go to bed, all of it has a real, direct impact on the amazing, complex chemical factory that is your body. And all those little choices we make, they add up. They create these huge public health trends. Just look at this number: 69%. That's how many adults in the US are estimated to be overweight or obese. And hey, this isn't about judgment at all. It's simply a biological fact, and it's one that has some pretty serious consequences. And yeah, those consequences can be really serious. We're talking about an increased risk for major health problems like diabetes, stroke, heart disease, even things like breast and colon cancer. So you see, understanding the biology behind this isn't just, good to know. It's basically a toolkit for taking care of yourself. And if you want a really stark visual, here it is: a smoker's lung next to a healthy lung. I mean, wow, you can literally see the difference, the damaged, blackened tissue from all the tar. But what you can't see is just as important. The damage goes deeper. We're talking about altered brain and liver chemistry. This is biology, plain and simple, showing the direct physical result of our choices. All right, so we've seen how biology plays out inside our own bodies. Now let's zoom out a bit, from your body to your own backyard. Because obviously biology doesn't just stop at our front door. So let me tell you this incredible story. Picture this. It's Minnesota, 1995. A bunch of middle school students are out on a field trip, doing what kids do, and they find something, well, something pretty shocking. Yeah, many of the frogs they found had serious deformities. Things like missing legs, extra legs, even missing eyes. Can you imagine being one of those kids? It was a huge biological mystery, and it kicked off this massive scientific investigation to figure out what in the world was happening to these frogs. So, of course, the scientists jumped on it. They did what scientists do. They followed the evidence. First, they came up with some ideas, right? Hypotheses. Could it be chemicals in the water? Maybe. What about UV radiation? Could be. Or, hey, maybe it was some kind of parasite or infection. They had to test everything, ruling things out one by one. And it turns out, like a lot of things in biology, the answer wasn't simple. It was this complex interaction of a few different things. The main culprit seems to have been an infection by tiny parasites, but there's more to it. And the investigation isn't totally over either. Scientists are still wondering if chemical pollution in the water might have weakened the frogs, making them more vulnerable to those parasites to begin with. And that story leads us right into one of the most exciting and maybe one of the most challenging fields in all of science today: biotech. We're talking about the promise and the peril of shaping the future of life itself. Now, I know biotechnology sounds like this super complicated high-tech thing, and it is, but at its heart, it's just the use and application of living things and biological processes. We've been doing it for centuries, making cheese, brewing beer, that's biotech. It's just that today, the tools we have are, wow, they're so much more powerful, right down to editing genes. And this is where you get this incredible tension between the promise and the peril. The promise is amazing, right? We've got bacteria that can make human insulin, we have crops that are resistant to insects, DNA evidence is freeing people who were wrongly convicted. But then there's the other side of the coin. What are the unknown long-term effects of GMOs? Who gets to see your genetic data? Should we be selecting for certain genes? These aren't just science questions, they're huge ethical dilemmas we all need to think about. For all the incredible things we've figured out, maybe the most exciting part about biology is how much we don't know. We're still standing at the edge of this vast, great unknown, with so many questions left to answer. I mean, just think about some of the big ones. Can cancer be cured for good? How do viruses actually mutate and change over time? A pretty relevant question these days, huh? And maybe the biggest of all, how are memories, your memories, who you are, how is that actually stored inside your brain? These are some of the biggest challenges of our time. And when we look for answers, we find that life here on Earth is just unbelievably tough. We find it in the most extreme places you can imagine. Deep under the ocean, living in frozen methane gas. Inside volcanic vents, where the water is literally boiling, life finds a way. It's ridiculously resilient. So that leads to the final, biggest question of all, doesn't it? If life can survive and even thrive in the most extreme places here on our planet, what if it exists somewhere else in the universe? Answering that one, well, that's going to be one of the greatest adventures in human history. And the explorers who take it on will need the most important tool they can have, a deep understanding of biology.